All right. And so there's nothing left of the old engine. That LS7 is done. The head is destroyed. The block is cracked. Even the crankshaft is all beaten up from parts rolling around and getting lodged in between the crank and the block. There's just nothing left to save there. So we need a new starting point. There's 3 different options. If you want to build a 7-liter, you can get the aluminum LS7 block. You can get the LSX, the bow tie LSX block in 427 dimensions, or you can get the Dart SHP. And the Dart they make in a couple of different flavors. I think they have LS Next, LS Next 2, and SHP, and this is the better of those. The crankshaft that's in it is 4340, and it has the extra material on the front to interact with LS7. The connecting rods are the 300M I-beam upgrade rods. It has ARP 2000 hardware throughout underneath, and the pistons are 7cc forged aluminum. This should be a very nice build. We've planned everything accordingly. I had a deck bridge on here. The piston is only like 4 or 5 thousandths below the deck at TDC. We can take this measurement with the thickness of our LSX head gaskets, which is 51 thousandths, and our measurement from the Brodix heads we're going to use, which are 71cc combustion chambers, and we can use the specs from our Cam Motion 8620 LS7 Stage 3 cam to understand what our static and dynamic compression expectation should be. And as we're building it, our static compression should be around 10.9 to 1, and our dynamic compression should be right around 8.3 to 1, which is perfect for running 93 pump gas down here in the hot Florida sun, being stuck in traffic and everything. In a better world, or in a racing car, or a better environment, we could try to shoot for 8.4, 8.5, but that extra little bit of headway really matters because of just different fuel grades, and also, like I'm saying, the hot climates we're subject to down here in Florida. It's time to start getting this together. The first thing going in is this Cam Motion cam. So here we have our LS7 engine block, and here we have our Dart SHP block. One of the big differences between the two, and there are differences between the two, and we can't really say that the LS is better than the Dart. I got arguments for why the Dart really isn't better than the LS, but if we were to look at a raw horsepower rating, the Dart blocks can come rated to handle up to 1700 horse, and the LS engine blocks are widely accepted to be reliable up to about 800 horse, and then after that you want to get one of the truck blocks, or if you want to get up to 2000 or over, you want one of the LSX blocks. Goes that rhetoric. So we can't say that because the Dart oiling system is different, it is suddenly less than the LS7, because that's just not true. Okay, so this that I'm pulling off right now, this is the camshaft thrust plate on LS7. This O-ring right here makes a seal, and no, there should never be RTV like this put on this seal, because right here is a main oil gallery that's cast into the block. This seal blocks the main oil gallery, and this RTV that squishes inside the seal is now a contaminant inside of the oil gallery that if it ever just broke loose, maybe it'll go and plug up a bearing and create a bearing to get starved for oil. That's just some silly stuff to see that should never happen, and I'm just now seeing that. Anyway, the difference between LS and Dart is the LS engine block has these oil gallery, like these reservoirs cast into the front and the back of the block for a crossover for the two oil galleries, okay? And so you get this camshaft thrust plate that has this big seal that crosses over the both of them and blocks it. On the back of the timing, or on the rear cover of the motor, there's also the same seal built into the gasket that goes on the rear cover to seal that housing on the back as well. On the Dart blocks, alternatively, we have all of our oil galleries are just drilled through the block, and then they have plugs on them. The plugs are here on the front face, the plugs are on the back face, and there are no exposed oil galleries on the front or rear. There appears to be a crossover cast into the block right at the midpoint, and I'm sure that's where the transfer is happening between the two sides. Because of this, the thrust plate for the camshaft is incredibly small and only has the hardware on it necessary to control the cam movement, and it's not worried about equal load and holding back oil pressure. C5R time and chain. The LS7 engine, as with all other LS engines, uses these tall lifter trays. These tall lifter trays bolt up high at the webbing of the block. One small bolt on the very top of the tray, and the trays extend down to come down to where the lifters are going to be working at. This setup requires the cylinder heads to be physically removed to gain access to the lifters. In early years, before the LS engine for Chevy, for Gen 1 and Gen 2, and same thing for a lot of Fords and others, we used to be able to access the lifters from inside of the valley. But when these newer generation of engines came out, everybody pretty much switched to lifters underneath the heads, and the heads have to come off on some cam upgrades if we want to also install a better set of lifters with them. Also, this is the valley. Let me reposition the camera, I'll show you the valley better. This is the valley of LS7. There is no access to anything. You can barely see one or two of the cam lobes if you look in these front or rear holes. But the the Gen 4 LS engine block has these provisions which would be drilled for displacement on demand, and the Gen 3 LS block still had standoffs for the NOx sensors in the middle of the valley. So there's always stuff in the middle of the valley with LS engines, and ever since Gen 3, there's just no access to the lifters from inside of the valley. Also, underneath this gasket too, we can see an all near the oil seal. Whole bunch of RTV just everywhere. It's a shame because these metal bonded rubber gaskets are supposed to be reusable. You're supposed to feel them when they're apart. You know, you clean them up, you feel them. And if the rubber feels thicker than the metal, and on these they do, you just clean them up and then you reuse them. Unfortunately on this one, we're just going to replace it, but this tells a tale when you see it that whoever put this heads and cam package on probably hasn't done this to too many LS engines that they're unfamiliar with how to work with metal bonded rubber gaskets. So these are the lifter trays that go in most LS engines. They're tall and they're designed to grab on the top of the lifters down by the cam where the lifters are at, but bolt up high on the webbing of the block up by where the head deck is. And that's why these have the 3 dimensions to them that they have. The Dart block uses the LSX style lifter guides. For LSX, GM made a change to take a step back and be able to regain access through the valley to the lifters. And the way that GM did this was they shortened these lifter trays significantly, and they reduced them down to their core minimum, which is just these little guides. They're special little guides. They're not for nothing. They got a little bolt inside of them, or a spacer that's actually pretty loose that floats around, but it doesn't fall out, thankfully. And there's a special set of bolts that go with them. They're M6 by 1.0, and they're 25 millimeter length, if you guys are looking for such. They're a lot smaller. They're a little bit more money. But they're better. And let me show you why. These are better because instead of having to come in through here, these can go in right through here, right through a window, and be positioned on. The bolt that holds it on can go right through the window and go right in. And there's one at every point. There's 4 windows on each side of the valley. 1, 2, 3, 4. And 4 on the other side. So once the heads go on, we don't have to take that apart just to change the lifters if we want to. With that said, it won't really matter too much. We're installing the best lifters that you can get in this build. Once this goes back together, being able to service the cam without taking off the heads is really going to be crucial. Aside from the fact that we're installing an ARP head stud kit, we have LSX style heads and block that we're mating together. And the Dart SHP has the extra 6 bolt per cylinder support of the LSX block. Let me show you what those head gaskets look like. These are GMPP 4.2 inch bore LSX head gaskets. And let me open. And you can see where the head gaskets have these extra holes. On top, or on bottom, the gasket goes this way. On top and on bottom of every cylinder, it's 8 extra bolts. Normally the LS engines have 4, 1, 2, 3, 4, or 1, 2, 3, 4, 1, 2, 1, 2, 1, 2, and these are the 4 bolts per cylinder, and then there's 5 bolts that go across the top, and that's what holds them in. So the LSX style requires both cylinder heads and a block that have the support, and then you got to get the gaskets, and then you got to get all the extra bolts. And we don't just have bolts, we have studs. And the ones that go up top aren't threaded in the block, they're threaded in the head. And so to install this, to get to these 4 on the top, you have to go in through the valley with a little stubby 3/8 wrench, and then put your torque wrench on that and work your washer and your stud and your nut on that. and it's just a pain, and it takes time to get these set up. And to be honest with you, the LSX head gaskets got a little bit of a price on them. They're not the end of the world, but these things just drive up the time it takes and the cost of doing the service. So to have this support where you don't even have to take the heads back off once we set it all up is just a powerfully nice thing to have, right? Because head gaskets on their own, these multi-layer steel head gaskets, they don't usually fail. They'll last forever, right? So as long as you're tuned right and you're running good and right and everything's going happy, you shouldn't have to take these back off. And the LSX style or this Dart SHP with the Brodix heads empowers that. Right there, right? Made in the USA. So are the pack springs. I believe the Brodix heads are too. The block was built here in the US. I don't know about where Dart casts their blocks at, but it's all high quality stuff going on this. So we've installed the new oil pump. We've torqued those bolts down to 18 foot-pounds. And before we put the timing cover on, I just want to take a minute and point out the importance of the LS7 oil pump hardware. All LS engines have these. I don't know if you guys can see that or not, but it's a little spacer that goes over the bolt. But they actually don't go over the bolt. They actually go inside of the holes that the bolts go through on the oil pump, and then these bolts go through these, and these center the oil pump perfectly on the block and align for LS7 the oil pump inlet and outlets perfectly with the oil pan. On other LS engines we can argue it's a little bit less important, but you're supposed to have these. You should always make sure you have these 4 of these sleeves on the 4 oil pump bolts on any LS engine going together. There's also 2 of these on the timing chain dampener to help keep it centered, and even on the timing chain tensioners for the truck motors. And the timing cover too. Nothing but RTV. Like, this cam package went in with RTV. This wasn't a cam package. This was a cam and RTV package. And it must have used multiple tubes of RTV for all of these gaskets to go back together, which should have felt very wrong for whoever was assembling this like this. It's not how we do. So the cam is installed, the cam sprocket's been torqued to 25 foot-pounds with the ARP hardware. The timing tensioner was torqued to 18 foot-pounds. The oil pump bolts were torqued to 18 foot-pounds. We're getting ready to put the timing cover on now. A couple of thoughts about the timing cover. First and foremost, it's very important that we try to remove and reinstall the camshaft position sensor on any of these Gen 4 motors anytime the timing cover is off. The cam sensor swells inside of the bore from exposure to oil over time, and it lodges and it becomes near impossible to get it out. And while the timing cover is off is just a great time to check and make sure that your camshaft sensor is not in a bind. And if it is, that's a great time to take care of it, so you're not stuck trying to drill a hole in the sensor and pull it out with a screw or something like that without worrying about sending bits inside the motor, or having to take the timing cover off and pull the balancer and the steering rack once the car is all together. I also like to put some fresh color on my covers. I know where I always tell everybody I like to leave the aluminum and paint my steel black, but raw aluminum actually looks kind of ugly. It stains and it becomes impossible to clean. So after I clean up my aluminum tin or whatever, I will always put some fresh aluminum color on it just so it looks like a new fresh part going back together, as this does. We also had a lot of fun on this one getting all the RTV off of it. I just can't say enough bad things about building with RTV. You know, it demonstrates a lack of concern or regard for servicing what you just built, right? This puts so much more work on the back end to get it back apart, to clean it up, to go back together, that the person that put it together like that clearly did not have many, if any, thoughts at all about warranty claims or working on the stuff that they just built. And so when you see stuff like that, you know, where it's visibly evident that the effort made in that job was just to get it together this one time, that should set off alarm bells for the most obvious of reasons. With that said, we press in the new crank seal with the spacer in place, and then we knock it out. This way the seal holds its true shape as it goes in, so it doesn't deform or distort. And we're using a new gasket that's made from Felpro. But I will not make any of them tight because I use the pan to center this level with the block. There's a couple of different ways of doing it. There's actually a kit. I'll show it to you. This is the specific tool for setting up these covers without having the pan on. For the time it takes to install this, set them up, and then torque these down and then put them back, it's really faster just to put the pan on, torque the bolts around the pan, and then torque the front cover in. And you know, you draw the covers down to the pan and then tighten them in. And that way it works a lot. It works just as well. I'll leave that at that. It's just faster than setting this up and then, you know, it's just one less thing to worry about. And now we're ready to put the oil pan on. Okay, this is the brand new set of heads we're using. These are Brodix BR7 heads. We got them new and sent them right out to the machine shop. They've already been prepped. And after taking a bunch of measurements, we decided to have them mill 10th thou off the heads. This will help us get our static compression and dynamic running compression up to where we want it to be. These heads are outfitted with stainless steel valves and PAC 1209X springs. Or 1208X. I think they're 1208X. I think we got the lighter springs. They do have 700 lift. The springs will support 700 lift, but we're not going to use that. We're only going to, I think, like 630. And that's it. These heads are beautiful. Brodix claim to fame is they have the strongest out of the box head, or that's the way it used to be anyway. I don't know if it still is that way, but they also have the strongest heads. They have 3/4 inch thick deck material, which is stronger than anybody else in the industry. So goes their rhetoric. We like the Brodix heads mainly because of how pretty they damn are underneath. If you guys look, Brodix CNCs, the combustion chambers. These things are beautiful, man. They're very polished and finished. Where LS and everybody else just uses as cast a lot, and then they focus on milling the ports. Brodix CNCs, their combustion chambers. They do still do some basic milling on the ports going in so that they have the same flange or same diameter flanges entering into the ports. And Brodix also brags and boasts on having a higher CFM flow rate for the same CC size ports, indicating that they just have a better port shaping or design to these heads. The other great reason that we like the Brodix and why we're using these heads specifically is for all of these extra bolt holes right here, these 4. And there's also more up top that you can't really see up top unless we flip this back upside down again. So these are the bottom bolts that get added for the LSX style. These bolts are easy to get to from outside the head. The stud and the nut will go down this way from outside. Easy to get to with the exhaust off. But these up top, we have to access through the valley of the motor with a wrench, and the threads are in the head. So the studs have to come in this way, and then the washers go up and then the nuts go up from upside down, or if you want to turn the engine upside down on the stand to set that hardware up. But it's a thing to get to it, and it's a thing to service it later on, which just really makes having the cutouts for the lifter access so nice for the LSX motors. All right, before these go on, we need to be very careful about measuring our piston to valve clearance because we have a completely custom rotating assembly and engine block, and we have custom cylinder heads, and we have a custom camshaft. I've done my diligence and my homework, and I'm pretty sure we're not going to have any fitment issues or any clearance issues. I do not expect the piston to touch the valves or them to get anywhere near each other, and I think we're going to land with our 80 and 100 on intake and exhaust at least. And we'll find out in the next video.